In this lesson, we're going to have a look at the most complicated effect yet. We're going to be breaking the glass of this Range Rover. So the idea is that when the shots are hitting the wall, right about here, we're going to have this window break. So one of the bullets is going to hit it and this is going to explode. The reason why this will be challenging is because we're going to have to fracture this geometry, and instead of doing an RVD sim, we're going to approach this with a particle simulation. So let's get started. I'm going to create over here a new geometry node for this effect, and I'm going to call it our glass shatter effects. And let's go inside of it, and the first thing I want to do is object merge the car. So we're going to go over here to our Range Rover, out geo. So you'll notice in here I already created a collision representation for it, just so we don't lose any time. I'm going to go over it later, but basically you want to select the geometry. I'm going to hide all the other objects, and let's zoom into it, and I want to bring the transform into this object. Okay, and the same as always, the first thing we're going to do is create a time blend. The first step is now to fracture this glass. So what I'm going to do is actually time shift this, and I'm going to choose a frame, like let's see, if we look at it from the camera, maybe this frame. So I'm going to say that this frame is when it starts to break. So see 1047. Okay, and then I'm going to select the windows. So I'm going to break it on both sides. So I'm going to break this one and this one. So we can delete this, and we're going to delete non-selected. Let's hide all the other objects, and I'm going to call this our window glass. And the reason why I'm fracturing is because this is going now more over to the RVD workflow, but whenever you have geometry that you want to fracture, you have to have it static, right? You can't be refracturing every single frame. It's going to give you a different result. So it's important that we choose a frame to work at. In this case, it's going to be 1047, and we're going to do our whole effect on this frame, and then we will reapply the animation. Okay, so fracturing. I'm just going to use a very basic Voronoi fracturing. We're not going to go very much in depth into it, but the basic idea is that we just connect over here the geometry we want to fracture, and then we scatter some points. And let's see, I'm going to turn off relax iterations, and then we can connect it here. So I think in our case we want a lot more points. Let's say maybe 4 times as many, so 4000. Okay, and then to see what this looks like, I'm going to create an exploded view. And the nice thing about this node is that it kind of scales everything. So you can see, yeah, that's basically going to be the size of our debris. But to make this more interesting, we're going to go over that very common technique that's used in fracturing, and that is we're going to be adding some noise to this so it doesn't look like a Voronoi pattern. It's usually very easy to tell when something is Voronoi. So let's see, I'm going to remesh this so we have more resolution. Going to set the hard edges group to be everything, and let's see, let's go into flat wire shaded. Let's see, let's go to 0.1, 0.5, let's see, maybe 0.3. And I think that's enough resolution. And then what you want to do is store the rest position. This is going to copy the position attribute into the rest, and you'll see why this is useful in a bit. And that is because I'm going to add an attribute noise. And in here, we're going to add some noise to the position. And then let's see, we want to probably center it, and I'm going to copy this parameter everywhere. So we probably want a lot less noise, and let's see, definitely a lot less frequency. So maybe something like that. Let's see, 1, maybe it's too much, 1.5. Okay, and now we're going to do our Voronoi fracture, and you'll see that the nice thing about this is that it's going to give us basically more interesting shapes. It's going to break up that straight line of the Voronoi look. Okay, and let's have a look at the result. And then now to get everything back in place, it's very simple. We're going to create a point wrangle, And now you'll see why we stored the rest as a separate attribute. That's because our position changed. But now if we tell the position to be equal to the rest, so if we just say at p is equal to p rest, like that, you'll see that it's going to go back. And now when we look at the exploded view, we're going to get way nicer fractures, right? Like this pattern looks a lot better than just the default Poronoid. Okay, and the next thing I want to do is I want to create a name attribute that we create ourselves. I don't like using the one the Voronoi gives us, so I'm going to attribute delete it. Usually create something, yeah, you can see there as a name. And the way I like to create it is by using connectivity. So we're going to create connectivity based on the primitive. And I'm going to call this a shard ID. So basically, all this will be our glass shards. And as far as the name goes, I'm going to create a primitive wrangle. And we're simply going to store the shard ID into the name. And before we do that, I like to, again, when I already have an ID, to make it start above 1. So I'll say shard ID plus equal to 1. So that's going to make it start at 1. And then for our name, I will say the name is equal to shard percentage D. And I'm going to wrap this around the sprintf function. So it's the same that we used before for the instance path. It's just that this time we're going to use the shard ID. And you'll see we're going to end up with a name and it has our shard ID. Okay. And we needed that to be at primitive level, but now we can promote back our shard ID. It's always useful to keep it here where at the point level. Okay. And now the next thing I'm going to do is I'm going to pack all this. So I'm going to use an assemble. And the reason why I'm doing that is because it's going to represent every single piece as a point. And that's exactly what we're going to use to simulate. So I'm going to turn on create pack geometry and I'll turn off create name attribute. And I want to make sure that we transfer the shard ID. Okay, so we're going to keep it here. And now if I create an add, for example, and I delete all the geometry but I keep the points, now we have our points here that are going to become the source of our simulation, and this will be the points where we're emitting from. Next comes the fun part, which is we have to create which points are going to be emitted into the simulation, the usual thing that we always do. So we need to have an impact point. We need to decide where the bullet is going to hit. So for that, I'm going to go back to the window. Now what we can do, for example, is select just a point. So I'm going to create, let's see, a null node over here. And this is going to become our impact point. And let's see, I'm going to click select and I want to turn off connected geometry. We don't want to select that anymore. We just want a single point. So let's see, in both sides, I'm going to try to choose the same one. I will press delete and delete non-selected. And we'll end up with 2 points in there. Okay, and this is now going to be our impact points. And what I want to do is I'm going to ray them back onto the glass. Sorry, I need to flip this. So I'll say minimum distance. Okay, and we can have a transform in here if we want. And this is going to allow us to move the point. So maybe we can move it somewhere there. So now this is going to become our impact points. So based on this, I want to transfer this attribute onto the window. So similar to what we were doing with the car. So I'm going to have here an emit attribute. So let's call it emit is equal to 1. So same here, emit 1. And then on this side, we're going to have our emit set to 0. We don't need that second input. So let's see, emit 0 and emit 0. We can give it a color as well. So just so it's easier to see. So this one is going to be black. And then these other points, I'm actually going to move them next to each other. So this other one is going to be white. And then we can do our normal attribute transfer. So we want to transfer the color onto our glass. And let's see, we want to transfer the emit in this case. Now we can transfer also the color. And I'm going to bring down the distance threshold. So you can see now this is going to be where our bullet hits the first time. And the idea behind this is that we're going to make this distance threshold grow, right, like that. And as it grows, we're going to be releasing it into the simulation. So now we can animate the distance threshold. So let's see, maybe go to 1047 and let's say that our distance is going to be 0. And then let's increase it to maybe 0.1, 0.5, let's see, 75, something like that. So that's going to be, I'm going to set a keyframe. And then let's go forward a few frames. So maybe, I don't know, until 1053. And I'll make sure that this is covering this again. So let's see, maybe 0.5, a bit more, something like that. And I'll set the keyframe. And let's see what this looks like. 48, it goes like that, and then it grows. So the idea of this is that the bullet is going to hit here, and this is going to be the expansion. So as this grows, all these pieces are going to start falling, and basically they're going to get released into the simulation. So see, maybe we can go a little bit lower, like maybe say 55, 56. There we go. Great. So the next thing is, I want to make these pieces only visible when they are supposed to go into the simulation. And you're going to find that this is going to be a problem. And the most obvious way would be to create a blast and to say if the color, for example, X is equal to 1, then let's delete non-selected, then let's emit this into the simulation. But then we have a problem because these are visible in all the frames. So it's going to emit these points, and then it's going to emit them again in the next frame, and then again in the next frame. So basically the amount of pieces are going to grow, and we only want them to emit the first frame they appear. So for that we need to create something that I call the release frame. So we have to figure out in what frame these points change from black to white. So for that, I'm going to create a new point wrangle. And the way we're going to do this is by creating an attribute called the release frame. So it's going to be called release frame, and it's going to be equal to the last frame that we have in our timeline. So maybe 1147 plus 1. I always like to go above the last frame of the frame range. And the idea is that whenever this is turning into white for the first time, the release frame is going to store the current frame number. The problem is that we have to keep track of what's happening in the previous frame. So for that, I'm going to create a solver. So the solver is actually a wrapper in SOPs. If you go inside, you can actually see that there's a DOP there. So we're inside a DOP network, and that allows us to use feedback. So the nice thing about this is that we have access over here to the previous frame. So I'm going to connect input 1, and in here we're going to connect the previous frame, and then I'm going to create an output. Okay, so the idea is that we're going to check the emit, and then we're going to check the emit of the previous frame. So we have to get the attribute, so it's going to be a float from the second input emit, and I'm going to connect the point number. Right, so we have, this is the current frame, and that's the previous frame in the second input. So we can say if the current emit is equal to 1, so that means if it's white, and then if the previous emit is equal to 0, right? So if both of these are true, and the way we can join these two compares together is using an AND. So we'll say if this is true and this is true. Now when we go into our two-way switch, we can say then our input 1 is going to be the current frame. If not, we're going to grab whatever is less, the current frame or the previous release frame. So that way we won't override it, because if we just leave it like this, let's see, we're going to export this to the release frame. You'll see that this won't entirely work. I mean, it's going to switch in this case to 0. See, we have to go out of the subsolver for it to cook, and we can see right now it's starting at 995, so we can tell it to start at 1047. Okay. And let's see, right now the release frame isn't changing. Let's go inside. I think it's because we have to complete our two-way switch. So okay, let's work on the second part. So now I want to grab the release frame. So let's just type here release frame. And I want to check what is less, if the current frame or the release frame. And whatever is less, that's going to be our second input. So release frame is probably going to be less. So let's say that, for example, in 1047 it changed. When we say what is less, 1055 or 1047, this is going to be less. So that's how we can keep our release frame constant, right? So once we find out what the value is, we need to make sure it stays. There you go. Now you can see that this is changing all the way from 48. Let's see, until, so right now it's not 1148. Sorry, that's at the end. I think we need to reset it. For some reason it's not working. So let's go inside. So had a typo in there. Okay. Now let's have it calculate again. And you can see there we go, 1048 and 1043. So it's keeping the frame where this is first happening. The problem about this is that now it's time dependent. So to make this not be time dependent, I'm going to time shift this. And I'm going to time shift it to the last frame, because we want it to run all the way until the end to find out when this is getting released. Okay. So you can see now we have this, which isn't time dependent, and we have the frame when we're supposed to delete this. So now if we delete this, actually, and we shouldn't have our delete here. I'm going to remove it. Okay, and now we can say if the release frame is equal to the current frame, and I think this isn't going to work in a blast, I'm going to do it in a delete, normal delete. So release frame is equal to frame, it's going to be a point. And then I think delete non-selected. Okay. And I think we're having an issue with point counts. Well, let's see, let's have this, let's reset the simulation. Okay, actually now it works. So now you can see these are only appearing in one frame. Okay, cool. So we're going to, this will be the last thing we use. So for now, we have to keep working after the time shift again with our non-time dependent geometry. So next we can start working on the velocity. So again, for that, I'm going to be reusing one of our setups. So let's see, maybe we can copy the one from the car debris. So I'm going to copy these two. Let's go back. Let's paste them. Okay, and I'm going to enable the visualizer for the velocity. Let's go back to auto update. And okay, let's see what we have. So we have over here our noise. And then we're doing a mix between our velocity and the normal, and then between the result of that and the app. So let's see, let's start working with this one. I'm going to move all this and let's build it one at a time. Okay, so we don't have any normal, and in this case I don't want to start with the normal yet. I want to get a vector that goes towards the impact. So that's more like what we did in the first lesson. So let's see. In order to do that, we need to connect in here our impact point, like that. And then what we're going to do is we can just subtract these two. So we can subtract the position, and I'm going to get the position so from the second input, and it's going to be, so we have 2 points. So in order to find which point is the impact of the window, I'm going to use a near point. So the way the near point works is you give it an input and you give it a position, and it's going to tell you what is the point number that is closest to. So in this case, this window is going to give us the point number of that impact, and the points here are going to return that one. Okay, so now we have that position, and if we look at that result now, we get this. Okay, and what we can do next is, so that this is perfectly aligned with the class, is we can do a cross product with our normal. So that's another thing we're going to need. So actually we can delete this for now, and let's see. So we have to get our normal, so we can do this right after the time shift. So in order to do that, I'm going to object merge the window. So let's see, let's go in here. So it's the window glass. I don't want to have just the wire going all along our network. And let's see, I'm going to just select a polygon on each side. So just that one and that one, and we can delete this. And I think this selected them on both sides. So let's see, I want to deselect that one. Okay, like that. And I'm going to delete non-selected. And let's make sure that these have a normal. So going to set it to points. And if we see, now we should have that normal. Okay. And now we can just actually transfer it onto our points, just like that. And now if we look here, these points are now going to have a normal. Okay, so that's useful. Now you can know what direction is out as well, and we can kind of know the angle of the window. Okay, so let's go back to our velocity direction, and in order to get this to be completely aligned with the window, you can see occasionally we have some vectors going in, and here as well. In this case, they're going out. What we can do is we can get the cross product of this with the normal. So let's see, just so that I don't have wires going over, I'm just going to copy this and paste it. So let's connect the normal in here. Let's make this smaller. Okay. So this isn't going to give us what we want, but now if we do the cross product of this and the normal again, so we're going to do a double cross product. Now you can see these are now perfectly aligned. So if we compare with what we had before, right, these weren't exactly aligned. We had some extra things going there. Now they are aligned. We just have to flip them because now they're pointing inwards. So that's just as easy as changing the inputs. So now I'm going to call this our outwards vector. So outwards direction. And then we can mix this, in this case, with our normal. So let's see. So we can mix this like that. And actually we should have a normalize in here. And let's have a normalize outside of it as well for the result. Just like that. Okay, and now with this bias we can control if the points are going to be emitting like upwards or outside. And I would like to use the distance to control this. So I want the impact, and everything close to the impact to really shoot outwards or inwards. We're going to take care of that in a bit. And then as we're further away from the impact, I kind of want the points to go maybe outside and to not go outwards or inside so much. So in order to do that, we need to get the distance to the impact. And I think we did that in the first lesson. I mean, we have it on the bullet impact somewhere. So if you go here, there we go, we're getting the distance and we're fitting it. So let's copy that setup in here. Okay, and I'm going to go full screen. And let's see, we can do this after the normal. So I'll paste this. So we want to get the distance from our impact point. So let's see, in this case, we need to add again, we don't want the distance from the position and the centroid, we want the distance from the current position and the position of the impact. So we're going to do the same that we did in the other point bob. We're going to grab the position from the second input, and I'm going to do a near point from the second input and our position, and that's going to be a point number, and that's going to be the distance. Okay, and then that's the result. And now if we turn off our velocity, we should see that if we look at this, this has been fit from 0 to 1. And now we have access to this distance that goes all the way from 0 to 1. So we can bind this. And as always, we can have a ramp with any value that's set to 0 to 1. We can change it to be a spline ramp, and I'm going to call this our disk ramp. And we can fit it so that we have a bit more control. And in this case, I'm only going to control the minimum, and I'm going to set this to normal amount. So normal direction amount. And this is now going to go here into the bias. So let's see. If we increase this, now we can see that everything in the center is pointing towards the normals, and like this, it's pointing upwards. So I think that we have to flip our ramp in this case. So now we can see everything in the center, it's pointing upwards. And then as it leaves, it starts to go, just outwards. And let's see, we can exaggerate this a bit more. Something like that. So now everything on the edge is going to shoot sideways, and then only this part is going to shoot outwards. Let's go full screen, and I'm going to bring in our noise again. And let's see, we can also bring in our up vector, I think, in this case. So let's add all of this in here. So let's say we can start with our direction in this case. Oops, that was the wrong input. So like that. So this is going to add our noise. And then this is going to add our up, if we want to add any up direction. Okay. So let's go ahead and adjust these values. So let's go out of this full screen and let's see what's going to be our up bias and all the stuff. So I'm going to set it to 0 for now. Let's start dealing with the noise. So let's go all the way to 1, just so we set our frequency. And I think actually this looks okay the way it is. I'm just going to lower the noise bias, maybe something like that. And then as far as the up bias goes, let's see, this is going to push everything a little bit up. And I think something like this is going to work. Now the final thing I'd like to add, I'm quite happy with this. I'd like to make some of the pieces go inside. So you can see now that everything is going out. And that's not very realistic. When a glass breaks, yeah, a lot of it is going to shoot out, but some of the pieces are going to end up inside, especially the ones that the bullet goes through. So one way of doing this is very simple, the theory. If you negate a vector, it means you're multiplying by 1. And you can see that basically you're flipping it, everything is going inside. So what I would like to do is to create a noise, and we're going to have some patches going in and some others going out. So let's see, we can add this. I like to add this before doing all this noise. So I'm going to be adding it in here. And to do this, I'm going to show a different concept that we haven't seen yet. And that is, I'm going to create a Voronoi noise. So same like we used for the fracture, but we're going to make it here in bobs. And let's see, we need the position. And that's going to be the input. And the nice thing of the Voronoi is that it gives us this seed value. And what you can do with this is, if you get a random out of it, I'm going to show you what this looks like. The easiest way to see it is if you connect it in the color. And by default, we're not seeing much because I think the frequency is too low. So let's see, let's promote this too. So I'm going to increase the frequency a lot more. Let's see, so now we start to see, you can see you get like these clusters. So what we can do is, we can now set these clusters, now that we have a value for them. We can say, for example, if you're less than a certain value, because right now we're getting a random out of them. So we're getting a value between 0 and 1. So we can compare, and you can say, if you're less than a certain amount, then we're going to negate the vector. Otherwise, it's going to remain the same. So basically, we're going to multiply by either 1 or -1. So we can say, for example, all the black clusters are going to negate our velocity, and all the white ones are going to leave it the way it is. So what we can do now is we can create a compare, and we can say, if this is less than a number, and I'm going to call this our inside-outside amount. So inside-outside amount. And we're going to end up fitting it between 0 and 1 to -1 and 1. And now we don't need to see the color anymore. I want to see the velocity. And all we're going to do is just, we're going to multiply this vector. Like that. And I'll make sure it's normalized. But it should be, but just in case. Okay, and now our inside is set to 100%. So you can see now, if it goes to 1, everything flips. So if we leave it halfway, for example, then half of the pieces are going in and the other half are going out. So we're going to end up changing this, but let's say in our case, I want most of it to go out. I want everything to be kind of explosive. So I think that is going to work. And we're going to come back to this later and tweak it, but for now I think this is looking okay. And next we have our velocity magnitude. So in here we just have standard things. In this case we don't have any speed, and I'm going to address that in a little bit. So we just want to have some noise. So let's see, we have our noise here and we're fitting it. Let's see, we can set it to -0.5 and 0.5. And in this case, I don't want to use our min and max noise yet. Actually, I'm going to delete this. I want to do something different. What I want to do is I want to have this noise be controlled by the distance. So I'm going to create a bind. We're going to bring in our distance. And we can have a ramp in here. And we're going to have a mix. So I want to make sure, the reason why I deleted this is because I want to make sure it's set to 0 and 1, because our distance is also set to 0 and 1. And this is going to become our dist ramp, like that. And I'm going to promote this. And I'm going to call it our noise amount. So noise amount. And in this case, again, since it says noise amount, and if it's 1, it should be full noise. So I'm going to flip them. Okay, and then we're going to multiply it. And before we multiply it, we're going to set our minimum and our maximum speed. So we're going to fit from 0 to 1 to our min speed and our maximum speed. And over here, our max speed. Okay, let's go back up. And let's see, in this case, again, I want to have this area near the impact to be the highest. I mean, the one with the fastest speed. So I'm going to invert it, and let's see, just so we can tell the difference, I'm going to set this to 5. And I'm going to set the noise amount to, let's see, 0. Let's see, let's have everything die off pretty fast. So as you can see, only the parts near the impact are going out fast. Everything else, as we go to the sides, the velocity starts to slow down a lot. It might be a lot easier to see if we change the inside and noise amount to, for example, I don't know, +5, so that everything is going out. So now you can really see that that part where the impact is the part with the highest velocity, I mean highest speed. So let's see, we can maybe set this to 1, I don't know, 2. We'll probably end up changing this later on. And let's see, as far as our noise goes, I'm just going to have very little. And we can remove this +5. It's just a bit confusing to see it when it goes inwards and outwards. Okay, and I think that's it for our velocity. Now, one thing you might be wondering is, why aren't we using the velocity of the car? And the reason for that is that we're going to be approaching the sim as if it was static, and we're going to go over this in the next class. But basically, we're going to be simulating in this frame at frame 1047, and we're not going to be using any velocity. We're going to be dealing with that afterwards. We're basically going to reapply the animation of the car onto the simulated pieces.